Hello everyone. Thank you for coming to my presentation and thank to my colleagues for explaining their topic. And my presentation is about the sustainable practices using technologies. Whenever we are talking about the technologies, so I mean BIM or Building Information Modeling. This topic actually can be much related to civil engineers, structural engineers, MEP engineers, and architectural engineers, etc. Okay, let's go to our presentation. BIM facilitates good sustainable building design through different areas, means buildings form, materials, context, and technical systems. First of all, let me to share a static report with you guys. Buildings consume close to 40% of all energy used in the United States and account for 40% of global CO2 emissions. The rising cost of energy and growing environmental concerns have pushed the demand for sustainable building facilities with minimal environmental impact through the use of environmental sensitive design and construction practices. Organizations such as the U.S. General Services Administration, or GSA, are increasingly requiring that architects, planners, and constructors meet this energy code in the delivery of federally owned building facilities. States such as Florida are following suit, requiring all state-owned buildings to meet standardized energy requirements. This type of green legislation is increasingly forcing architects, planners, and builders to consider the environmental impact of the building they design and construct. What is the BIM really? And let's see, actually, the building information modeling that we are talking about, what is actually. Building information modeling represents the process of development and use of a computer-generated model to simulate the planning, design, construction, and operation of a building facility. The resulting model, a building information model, let's say, is a data-rich, object-oriented, intelligent, and parametric digital representation of the building facility from which views and data appropriate to various users' needs can be extracted and analyzed to generate information that can be used to make decisions and improve the process of delivering the facility. BIM uses parametric object modeling technology to create relationships between objects within a virtual building model. These relationships include physical and functional characteristics as well as project life cycle information. A recent research study has indicated that average BIM return of investment ranges from 664% to 1,633%, which clearly shows its economic benefits. We know that the most effective decisions related with sustainable design of a building facility are made in the early decision and pre-construction stages. Traditional CAD planning environments do not support the possibility of such early decision. Energy and performance analysis are typically performed after the architectural design and construction documents have been produced. This lack of integration into the design process leads to an inefficient process of retroactivity, modifying the design to achieve a set of performance criteria. In order to assess building performance in the early design and pre-construction phases realistically, access to a comprehensive set of knowledge regarding a building's form, material, context, and technical system are required because building information modeling allows for multidisciplinary information to be superimposed within one model. It creates an opportunity for sustainability measures and performance analysis to be performed throughout the design process. We know, and it's very clear that as with traditional physical models and drawings, evaluating building performance based on the graphic representations of conventional CAD or object CAD solutions requires a great deal of human intervention and interpretation, which renders the analysis too costly and time-consuming. A survey conducted by the Center for Integrated Facility Engineering at Stanford University cited that economic reasons are among the primary causes for not implementing sustainable design and construction procedures by the majority of survey respondents. If I want to give you an example, I can say that BIM can reduce the cost associated with traditional energy, while also realizing the benefits associated with energy analysis by making the information required for sustainable design, analysis, and certification routinely available simply as a byproduct of the standard design process. BIM, or Building Information Modeling, provides the opportunity to realize numbers benefit throughout the project conception, design, construction, and post-occupancy phases of a building facility using advanced technologies, tools, or software. Linking the building model to energy analysis tools allows for evaluation of energy use during the early design phases. This is not possible using traditional 2D tools, which require that a separate energy analysis be performed at the end of the design process, thus reducing the opportunities for the early modifications that could improve the building's energy performance. So here we understand how BIM is related to cost or can reduce the cost. In terms of levels, because in BIM we have different levels, and for a BIM modeler or BIM manager, it is mandatory to know about the levels. Let's talk about BIM levels. Changing BIM sophistications level within a company's operational policy represent the different BIM grades of usage, which can be summarized in this figure that you can see. Let's see what do these levels mean. So we have level 0 or level 1, level 1 or level 2, level 2 or level 3, level 3 or level 4. Actually here I just mentioned both types of level that BIM managers or BIM modelers use. So either they call level 0 to 3 or level 1 to 4. Okay, so let's talk about the for example level 0 to 3. What are these levels? Okay, level 0 is undamaged CAD, possibly in 2D and using paper or electronic paper even as the main data exchange mechanism. So we can say that for example a PDF file, so you can consider as level 0. Level 1, managed CAD in 2D or 3D format utilizing a collaboration tool that creates a common data sharing space. Level 2, managed 3D environmental held in separate discipline BIM tool with attached data. Commercial data will be managed by exclusive interfaces of bespoke middleware. This level of BIM may utilize 4D construction sequencing and 5D cost estimation or information. For example, some countries like the UK government requires that the industry needs to achieve BIM level 2 since 2016. Level 3, fully integrated and collaborative process enhanced by cloud-based capabilities or cloud-based system and utilizing 4D construction sequencing, 5D cost information, and 6D project life cycle management information. So once again, I have to mention that sometimes the aforesaid levels are presented as level 1, 2, 3, and 4. The important point is how can we understand in which level we are or looking for. Well, we talked about BIM levels. Now here, let's talk about the BIM dimensions and how these dimensions can be related to sustainability once again. The capabilities of BIM vary from a 3D model to higher dimensional models, maybe 6D, 7D, because 7D is the just recent dimension that introduced by the specialists, which include sustainability features such as energy performance characteristics and facility management application that cover a project's maintenance and operational features. You can see the various BIM dimensions as shown in this figure. As we can see in the figure, BIM connect with sustainability in dimension 6. In order to understand it better, let me give you an example about item number 4 under 6D, which is leadership in energy and environmental design, or we call it LEED, L-E-E-D. For projects pursuing LEED certification, many LEED credits require that drawings be submitted to support the qualification for credit, although most of this drawing can be prepared using conventional CAD software. BIM software produces these drawings more efficiently as part of the building information model and have the added advantage of parametric change technology, which coordinates changes and maintains consistency at all times. Thus, the user does not have to manually update drawings or links. Similarly, such models carry a wealth of information for many other aspects of sustainable design and LEED certification. For instance, schedules of building components can be obtained directly from the model to determine percentage of material reuse, recycling, or salvage. In addition, advanced visualization techniques can convince unbelieving clients that green design performs well and looks good. In general, we believe that BIM can aid in the following aspects of sustainable design: building orientation, building massing, daylighting analysis, water harvesting, energy modeling, and sustainable materials. Okay, let's a bit talk about these parameters. So for example, building orientation is to select the best building orientation that result in minimum energy costs. Or for example, building massing is to analyze building form and optimize the building envelope. Or water harvesting is to reduce water needs in building. Or energy modeling is to reduce energy needs and analyze renewable energy options such as solar energy. And finally, sustainable materials is to reduce material needs and to use recycled material. Six potential strategies to reduce the environmental impact of a structural system can be identified using BIM process. The figure here shows the diagrammatic representation of this framework. Two main categories are identified, as you can see in this figure: lifetime structural engineering and eco-efficiency of structures. The lifetime structural engineering category refers to the whole life cycle of the structure, focusing on the initial construction process as well as the post-completion phases impacts. The measures which are included within this group are durability of structural elements, maintenance requirements of structure, future flexibility, design for deconstruction. But what are these terms meaning? Durability of structural elements, it achieves the balance between the needs for maintenance and replacement of the structural components over the life cycle of a building. Maintenance requirements, it increases the durability of the structural elements and associated environmental impact benefits. Future flexibility provides the structural system with flexibility other than the changing requirement from its occupant. And design for the construction designs the structural component in such a way that it maximizes reuse and recycle potential at the end of the structure's life. Okay, so the second group, which is the lifetime structural, which is the eco-efficiency of the structure, on the other hand, refers only to the primary environmental impacts of the structure, and it includes the putting the material in the right place and the specification of materials, which is the most studied field within the sustainability of structures. In regards to the specification of materials, two main features can be identified: reducing the environmental impact of conventional structural materials such as recycling aggregates as a cement replacement in RC structures, for example. And another one, building with alternative environmentally friendly materials such as green concrete. However, according to research, these materials often raise liability and technical issues. The second approach, putting the material in the right place, refers to practices that focus on designing structural elements with reduced initial environmental impact. This category is strongly related to the structural engineer's design decisions. Again, a BIM integrated structural optimization framework can be explored to investigate the sustainable use of materials in the structural systems. For better understanding, let me to give you an example. This figure shows the overview of a model with the interrelation between the individual components. So here I mentioned, or I brought some software to just actually convey my message to you in a better way. So for example, here Revit software is the core of the cloud model, where all the participants can exchange, download, and upload drawings, design information, policy requirements, and design objectives. In regard to the 3D model description, two approaches can be applied. In the first one, the parametric 3D BIM model can be imported into robot or RobOpt, or as the second alternative, the 3D geometry can be generated and verified within robot or RobOpt, and sustainability, it can be transformed back into the BIM Revit model. So here, when we are talking about the robot and RobOpt, so here just I wanted to explain the optimization. So for example, here we have the robot software. It is the analysis software for, let's say, analysis and design of a structure, and RobOpt is the optimization tool. So we can connect this software to each other to actually achieve the BIM process. Let's assume that the user identifies a single bay steel framed structural system with a set of 3D nodes coordinates. After the 3D model is defined in RobOpt, so which is it is the optimization tool, various structural inputs can further be assigned, including load cases, steel sections, and supports, using the robot engine. So robot engine, we said that it is the analysis and design tool. So it can be based on the different code. For example, Eurocode verification can be performed for the design configuration, and the analysis can be visualized within RobOpt, or it can be exported and processed within external application. In RobOpt, the integrated GA or generic algorithm optimization searches for the custom I-beam section that minimizes the overall structural weight and maximizes the efficiency ratio of the frame. The proposed custom steel section automatically updates the model in robot. The new information model updates the BIM definition along with material quantities and properties. The embedded life cycle assessment analysis in TOLI can then be established based on BIM model. And in this manner, a full assessment of comparative studies of the potential environmental impact can be performed. So here I just brought an example of BIM process to reduce the environmental impacts of a structure. If I talk here about mentioned software, it doesn't mean that you can go through a BIM process only using these tools. In the next slide, I will fairly list some of advanced tools or software which you can use them for your BIM projects. So here, let me briefly talk about the IFC format. Okay, just wait a moment, please. Yeah, another thing which I need to tell you here is about the exchanging data from a software to another. In this regard, there are many available formats which you can exchange your data, but the most advanced format is Industry Foundation Classes format, or IFC format, that we know it as IFC format. Actually, IFC provides an interoperability solution between different software applications. The format establishes international standard to import and export building objects and their properties. IFC improves communication, productivity, delivery time, and quality throughout the life cycle of a building. It reduces the loss of information during transmissions from one application to another, with established standard for common objects in the building industry. Nowadays, many software that we are using have the option for import and export IFC format. Thus, easily we can transfer data from a field to another, such as architectural, structural, mechanical, electrical, plumbing, accounting, etc. I would like to share one of my BIM experience, because I was working as one of the BIM manager in MR2 in MRT line 2 project SSP, or Songhai Bolo Serdang Putrajaya line last year. In that project, we were using a DGN format, file format, for producing the digital drawing of the underground works, or let's say tunnels. The engineers of lead consultant were using RVT format. So RVT is from Revit, and DGN that we were using was from Ecosystem Building Designer. So for exchanging the data from DGN to Revit or RVT format, so what was the solution? How we could actually, transfer our drawing from the DGN format or Ecosystem Building Designer to Revit to pass the information to another team of engineers. So the IFC format was the solution, and we did it successfully. And finally here, I just, as I mentioned previously, so you have actually, a variety of choices for working with BIM process. The only thing is that we need to understand the levels, as I mentioned before, and also the some process like exchange data format. So we have to aware of those format. And also I have to mention that IFC is not the only format, but it is the advanced format. But also you can use other format like XML, like STL or SAT format. So you can use a variety of formats to exchange your data. But here just I actually want to present a number of software or tool, or let's say technologies, that you can use. So it doesn't matter you are using the Tekla solution, you are using the Bentley solution, you are using the CSI solution, SIPE solution, doesn't matter. So the matter is how we can actually, professionally exchange our data through the entire project. Thank you so much. And if you have any question, so maybe I can answer your question. And if you have any, future inquiry, you can email me at khaled@pasofal.com or khaled@pasofal.com. Thank you so much for being with me. Thank you so much.